I'll be talking about Speckle LCA. It's early phase carbon calculations then. And so I'm Fabian. And I work at Arkitektur. So we're an architectural company in Scandinavia primarily. So we're 3 countries, Sweden, Denmark, and Norway. And we're 500 employees plus, and we're spread out all over the place in Scandinavia. But we mostly work in Scandinavian countries. So we're also a part of the IO team, it's called, which is our internal development group. And we are 9 to 10 people, depending on the month. And we do all our internal computational design and parametric workflows, but also app development, which we will look at more today then. It's also some research projects as well. So our tech stacks looks like this. So usually we talk about LinkEP, which is our C# Rhino plugin, but now we will focus more on Speckle and WebView and the LCA app for that. But just to mention that we do C# development as well and our own Rhino and Grasshopper plugins. So inside of Speckle, we have a lot of workflows. We are sending it directly to our internal C# app. We are sending it to daylight calculations. We're using it for documentation and like result and report generation. If you were at the Copenhagen community meetup, you heard Joel talk about these different steps, but let's focus on the green cube up. And so what it is, it's an open source LCA app. It's built upon Speckle, but it's made to be extendable for other, but Speckle is a main data break for it. It's using LCAX and EPDX for data conversion and storing the EPD data, which Christian made. And we are the main developers, but we have 8 contributors towards the GitHub. And it's a larger project group. Quite a lot of people here has been involved in the workshops and discussions surrounding this. But it is kind of beta, so if you want to run it, don't expect everything to work 100%. It's kind of ongoing. So our tech stack for the application is a Vue 3 application. It's using Pinya, TypeScript, Vite, and Tailwind as the main kind of cornerstones. And for this, we will go through a kind of technical how it's built and why we have built it as such. So it's 7 modules, starting with a connector. And let's have a look. So the connector is our way into the data. We're using Speckle as a project database. We select a project, we load our version that we want, and in the background, we're converting everything to geometry objects, as we call them, and project data. So we're basically taking the data we get from Speckle and then creating our own object by it, just so we strip down all the unnecessary information. We don't need the 3D information for the Speckle mapping or for the LCA mapping. And the geometry objects, so first we have a project, and inside of that we have a focus on how our project is built up, because you need that for many, but let's focus on the geometry objects here. So it's a very simple structure. We just have an ID, a name, and URL, and the URL is actually the Speckle object. And we take out some quantities just to have them at the same place at all the times, because when you're sending from different applications, they get mixed up a little bit, but we convert it. And we made this so we can extend these guys. So the geometry object can be extended if you want to add a material to it or a result to it. You just simply push another object towards it, another property. And all of these have metadata attached to them. So the application, once we're done with selecting a project, we go into the kind of viewer mode, the application mode. The application uses a 5-step process. So first you select your project, then you go into and do your filtering and overviewing your project, quality assurance. Then you map it, then you get some results, and then you benchmark this towards other previous calculations. And the application has a left bar, which is this main data viewer. It has a 3D bar, or a 3D area where you kind of quality ensure and view your project. So let's get into module number 1, that's filtering. And the filtering is kind of the cornerstone of this whole application. So we're getting a dynamic list of properties. from the Speckle model. We're getting everything, we're data dumping it down, and then you can start to create new filters from this. And this can be anything from category in Revit or whatever material you have mapped to it. So let's say it's a brown color of the object, and you know it's a wood object, depending on what phase you're in. So we're creating these kind of filterings to create a tree structure. So this is already like this filters is already in Speckle from the start. But if you want multiple levels, or if you want to exclude something that has like an area of 50 or above, or that doesn't have a square meter, or it's equal to some kind of ID, then you need to be able to create these smarter tree structures, kind of, or these more advanced tree structures. And we're always using a two-way connection. So you can select something in your data list or in the viewer, and it's going to be selected inside of the 3D viewer. So you can see that actually the objects come in correctly and they have the right places in the model. And you can always switch between like a diagram mode and a rendered mode. So you can get some nicer graphics on how the model is actually split up, and you start to see these differences. And once you've, you can have like a infinite list here of different filters and create how deep a data structure that you need to be able to make a mapping. And once you've done this, you can save it down, and then it's able to be reloaded for another project. So basically, our filters are like on 3 different levels. You have the generic ones, which are for everything. You have source-bound, which are Revit filters, and you have project-specific ones that you've set up specifically for this BIM-type project or whatever it is. And when you load it, it's gonna pop up, show you the same filtering as you did before, and you can like redo your work. And it's pretty simple to set up, and they are very expandable. So it's basically Boolean operations. When you create it, it's a comparison. If you want a comparison filter, it's just do you want it equals or not, and then you just, right now it's code, but it's pretty simple at least. So that's kind of the cornerstone, but you can't do an LCA without materials and the mapping. So we've made it so that you can connect any data source that you want, as long as you're converting it to EPDX at the end. But here we have our mapping view, and the diagrammatic view here is red to green. Red equals not mapped, green equals mapped, so just to have something simple. And you also see a bar there at the side where you kind of see how much of this structure has been mapped. So when you start mapping materials, you will get a material list where you see all your materials. You can search through them, you can filter through them. You drag and drop them onto your group. Now they're mapped, now they're applied to this material, and you have them to be able to calculate the carbon emission of it. And it's using the exact same structure as you set up in the filtering, so it's kind of reproducing this. And you can see now in the viewer you have greens, and in the bar it's starting to progress. You've made a good job. So this material list, we have some kind of basic filtering and sorting, but it's pretty rudimentary for now. But you can sort based on name, unit, emissions, or whatever you add here. It's just as long as it exists on the material basis, you can sort on it. And then we are filtering on it. So we're checking sources, we're checking material types, and then also units. So this is how you can kind of find you only want materials that you can map towards cubic meters or something like that. And when you apply the material, it's going to use the quantity that exists in the model and on that object. So if you use a cubic meter material, it's going to use the volume. And if you use a square meter or a meter, it's going to use the length and so on. So it's dynamic in that way. But these are also easy to add new. It's just you choose what kind of parameter you want to filter on, and then you add it. So, but let's talk a little bit about sources, because that's kind of the bread and butter of carbon analysis. So right now we have 4 main sources. We're using LCA Big, which is a stolen material library from a hackathon. So, but that's kind of the one that is being used at the start. And then you have a custom JSON one. And then we're using something called Revaloo and Echo Portal. And for like EPDX, it's super simple because there's already a conversion for Echo Portal, which we use. So let's like zoom in a little bit on Revaloo just to have an idea of how you can import your own material libraries into this. and how you use it. So at Link, we've created like a standard. These are the ones that we use for projects. These are the materials that are best case use for us, and you have like different levels of how good they are and cost relationship and stuff like that. And inside the application then, we move into our mapping, and then we choose that we only want to see using our Revolute collection instead of using the material type, for example. We can find our insulation materials, we can find the best practice one that we want to use, and just apply that. And the nice part about Revolute for us is that we can also attach, you can send back stuff, so we can track material usage, so you can also kind of apply a tag on it or something like that. And we also implemented a direct search. If you ever copy a like UUID for an EPD, you get it inside the application directly. So you don't have to load everything from start. You can just get it if you know that it exists. But as we've heard, most of the time for early phase projects, we use assemblies or constructions or depending on what the system, what you call them. So of course you can create them here. It's like on a 2D basis or even less maybe on a diagrammatic basis that you create them. So you add your materials, it's going to compile all of them, and you choose what thickness they have and what building codes they represent. So it's a very simple system, but just to be able to create these, and you can import these for a JSON format if you already have them. We have our own list since before for our uses of how we build our materials, so it's quite easy to implement. But since we're using most of the time Rhino data for early phase, which doesn't have like building part codes and stuff like that, which you need for carbon emission calculations if you want to certify it, then we're setting it on these materials as well. So every time you apply this towards a generic object, it becomes like an external load-bearing wall, for example, because it knows that this is the construction of an external load-bearing wall. So it's quite easy, and you can kind of split these. You can calculate them as one big thing or split them out in their parts as well. So our mapping is done. We save this. And once we've saved it, we can load them back up, and we can do some optioneering with this. So we can save our concrete structure, our hybrid structure, our wooden structures, and kind of just load them in again. And how this is saved is that we're using it's not saving it per object basis, because that would create some issues if you remove a wall and you add a new wall. It has a different ID. So we're adding them by logic instead. So every time you're mapping a material, it's actually checking what filter you have currently. It's checking what material you're dropping on what group, and then it's remaking that. So if you ever had a filter that sorts everything on, let's say, brown colors for early phase Rhino stuff, then that's wood. Then you load another Rhino model, has the same color scheme, because that's your BIM standard or your Rhino standard, auto-mapping it. You don't have to redo it again. So that's kind of the main thought. You map once, and then you're done, kind of. So the solver, I won't get into this because it's super lightweight, and it's all done client side. We don't have a server doing any calculations. So there's some authentication that is being done, that's server side. But the calculation is super simple. It's basically quantity times emission value. So it's not something that interesting, but we're doing this on object basis, so we can filter it later on. So it's only the mapping that is done by logic, but this is object. And we will add we will add a settings panel sometime, but right now it's just taking everything and dumping it down and saving it as results. And we're focusing on GWPs right now, but if you need something else really niche, you can add it, because if it exists in the material, we can just calculate it. But the calculation engine is made to be flexible, but right now it's hard-coded, so it's not that flexible. But that's to be added. So in our results view, now you've done your mapping, you want to calculate, get your results. Then in our diagrammatic view, we have a gradient, which is using a logarithmic scale, where red is high and green is low emissions, based on both material and size of the objects. You can find your hotspots. And when you're moving towards this, it's doing all the calculations, and since it's pretty fast, you have all your information inside the Speckle objects, and it's being converted into the geometry objects, we can start filter on it. So we have 3 main graphs. We have our pie chart in the top right corner, where you can select. So it's two-way here again. If you select something in the pie chart, it's going to select it in the 3D viewer. If you select something in the 3D viewer, it's going to show you it in the pie chart. And then we have the detail bar at the bottom where you see the emissions by phase. So it's more like drilling down into it, and you can really see where the emissions are on the project. And then we have like a bar chart hotspot thing where you can choose. This is checking on material types right now, but this can be anything. This could be construction phases or whatever category you choose to show it on. But it's always this two-way interactivity, so you can really find where the specifics are. And in this project, you could really see like the electrical furnace. So depending on your detail level, you can go really detailed or very rough. And why it's interesting that it's a modular system is that we can exclude them. So that's why it's made like this. So every module here has its own PINIA store, and it's only interacting through utils. So what that does is that we can remove a lot of stuff and just keep some of them. So here we're looking at a daylight analysis that we sent instead. So we're doing no calculations. It's just showing results and filtering results. And we're using the same framework. So you can have your graphs and you can have your different thresholds and all that. That's easily adaptable when you're sending the object. You're sending the stream. You can send your settings on this. So here we can find all our rooms which have a proper daylight or a negative daylight. This is daylight autonomy, so that's why it looks a little bit weird if you're used to daylight factor. So the nice part is that you can both add modules if you want to, future-wise. Let's say you want to add cost to this or something else, like a structural calculation, but you can also remove, which is most of the case what we do, kind of. So it's basically just coupling graphs with Speckle data. So if you send it and you have it as a value object attached to it, so this is sent from Grasshopper, then it will display here, showing the results inside of it. So how does this integrate then? So I'll show some use cases, but we work at Link, we are software agnostic, at least that's what we kind of say, but we use Revit, Rhino, and ArchiCAD. So for us, having like a nice workflow between all of them has been pretty problematic most of the time. And we wanted to have possibilities for iterative modeling and more direct connections with the models. So let's look at Materialdepån, which is an industrial project in Sweden, and it's construction phase. And we've used it on this project to kind of help communicate better with our architects and the clients. So this was a pretty fast project, but it had very high BIM standards. And we were forced to model it according to the customer specific rules, so we couldn't use our pre-made mappings. But we had our experts create these mappings, and then from them we just loaded them in using our auto mapping feature, so it's already made. And we can reuse this for any version in the future that has been made. And we set it on our standard objects, and you can see when we switch between them that sometimes it will miss some objects, and you will have a red bar showing, highlighting kind of the missing objects in this process. But this is a very late phase project. You have a lot of detailing already in here, but then the interesting part for this project kind of came in. This is just a repetition of the mapping, but it's how the mapping ends up. So you basically have your filters and you have all your steps, and then you have the materials based on these steps and how they were applied. So you can go in. There should be an interface for this. There isn't. So you have to go into this file and change it. But in the future, it would be nice to have where you can swap out materials. So maybe you added one at the top level that wasn't the best choice. Then you can swap that out, and then it will cascade down and remap everything for you. So usually this is how we communicate towards the client, okay, we have a concrete structure, it's bad. Then we have a hybrid structure, it's a little less bad, and the wood, it's really good. But for an industrial project, this is not our typical project. At Link, we usually do hospitals or schools and stuff like that, and housing projects. So for us, we had to kind of both internally and externally be able to show where the bad spots are in this project. Where are the problematic areas for an industrial building? So using a wooden construction, where are the actual emission values in the model? So you can see in red here that you have a concrete foundation slab in the bottom that is very problematic and has very high emissions. So if we can change that out, we will gain very big loads or very big gains in carbon emission. And also on an industrial building, you have very large slabs, because it's the relationship between slabs and internal walls is very big. And the same thing with roofs. So if we can reduce the roof construction, then we will gain a lot. And this is kind of, for us, it's a very good way to show how your mapping efforts and how your LCA efforts actually affect the project. And do you have a big, this hasn't included any foundation work with pooling and stuff like that, but then you can usually see that the steel, like foundation slabs, the steel structural, that the what do you call it, drilling for the foundations, that is usually a very big factor in the project. But here, when we switch from a concrete structure to a wooden structure, you can see that the walls, the internal walls have less emissions now and are better. And when we can switch out the concrete slabs in the middle of the structure towards wooden construction instead of concrete, we're gaining a lot as well. So it's almost like making the result diagram that we've shown before in a 3D way. So Degne Jordan, it's a Danish project, and this is more how you can use it throughout the project from sketch to construction. And it's a Danish housing project, and they had very high sustainability goals. And I'll just mention this is part of what we did in this sustainability work. We also did like microclimate and all this energy calculations on this project, but this is focused on the LCA now. So early phase, we have a Rhino model. It's super basic, it's just a volume. We have our Grasshopper script that sends this basic Rhino model into Speckle. And what we did, so I'll also mention, this was from like old time. So this was 3 years ago. This app didn't exist then. So we did this through Grasshopper and Excel, and it was the same process, but this is now new and improved. And also we used Plan Finder then, now we use Finch. Small differences. So basically we take this, and instead of using dummy values, which we are already using and applying to it, we also thought, yes, maybe it's fun to generate a floor plan. This floor plan might not be the best one to live in, but we can use it to calculate emissions. So we take this, we auto-map it, we make our mappings, we send it up. So then we can start doing changes. We start to extrude this model, or this is a very simplistic modeling setup, but we extrude it, we generate a new plan, we get our new dummy values, we send all of this information, and we map it. And then it's AI, so walls are sticking out of the roof, that happens, but then we continue, we do the same process, you change your model, you get your AI plan, you do your mapping. And this is kind of to integrate the structure and show that you can really push it and start to make quick changes. Since the Speckle send is very fast, you can just do your modeling, apply whatever process you need, and then through Grasshopper send the geometry. And this is from our view inside of the application, and you can see that for the interior walls, we start to have functions. Because when we're doing it with AI, you also get the room functions. So you get like, this is a bathroom. Okay, a bathroom usually has a gypsum wall that is waterproof. Then that's higher emission. And if you have a kitchen, you can start to count and use better dummy values because you have the area of the kitchen, and you can not just use the, like, there will be a stove and there will be some heating, plumbing. You can get some better values that are more concrete. So that's kind of the process for the early phase. And then we go into detailing, more detailed. We start to do facades. This was also done in Rhino here because there were renders done on this, so they preferred Rhino. And the model is quite detailed, but it's the same structure. You have created our volumetric houses, and it's being applied a facade to it. We have our floor plans that are being generated, and the layer combinations, the layers has been more defined, and the detailing has been more defined. So the script increases, adds a few categories, and since we've done the mapping once inside of the application, we can load this, and when we start to have a look at the project, we can see that we have our phase 1 mapping that we already made. We get automatic mappings from it. It's going to filter it based on how you did before. And you can see that interior walls, they're the same. You already have them mapped. You don't need to do anything, but some places you will have less detailing on it because it didn't have it before. So the ribs, for example, in the facade, those were non-existent before. Now they are there. So before we just had an assembly placed on top of the external walls, but now we need to add the detailing as well. So we're like inheriting everything from before, but being able to add onto it and create this kind of iterative process where you add more and more details towards your project and you kind of build the analysis based on it instead of redoing it every time, which is kind of the common practice today. So the final step in this project was that we moved it to Revit, did our detailing there, and they kind of coexisted for quite a while. So it's not like 1, 2, 3, but it's more like 1, 2, a bit, and then 3. So we take all our geometry from Revit, and Speckle takes everything, so we can have our model groups, exploding them automatically for the application, and we're not really caring about the data structure that comes into Speckle because we're checking it per object basis and then creating our own structures. So it doesn't matter like if they did something weird and did something with modules that shouldn't be in modules or something like that in Revit. So we can just take our mapping from phase 2. You can see that, okay, we're missing some parts. Now I've made it TV chef style, so I already prepared it. So we have our phase 3. Yep, everything is filled in that needs to be filled in. And we can kind of see there's some plants here and stuff like that, but we've built upon it and we can start to load it. Here you could start do some optioneering. You could do that from the start. You could have like a wooden structure, option 1, phase 1, concrete, phase 1, and so on, but building on the same thing. And in the end, you will see the results based on the mapping that has been made. And like it has provided the architects more like an easier way to view the project because they're known to the 3D environment, but also an easier way to show where your emissions actually are, which was good for this kind of project where the sustainability goals were pretty high. So instead of just having a square meter value and a threshold, you could see that actually these windows are performing very well, but these ones are not as well because they're aluminum and so on. So, but that's the presentation. So the GitHub, if anyone wants to contribute or have it running, just contact me and we can set it up. There's no static page set up. The one that is set up on the GitHub now is old, but I'll update it someday.
Thank you. Pop quiz. My name is... Okay, I tried. Do we have any questions? Yes, sir. Try to be funny and they just don't ever laugh at your jokes.
You're good at it. Can you share what kind of contributions you are looking for this project?
So the UI needs some love. The results would need some love. We need to update from viewer 1.0 to 2.0. That would also be very fun if someone would take that on. And also adding more modules if that's interesting, if you want like any other analysis done that can be lightweight and done in the browser, basically.
Got it.
Thank you. Anybody else? Yes, you may.
Hi, Fabian. Behind the column. I'm just curious if you notice any discrepancies from the very early stage AI, evaluation to the very end one, full-blown model in Revit. Was the numbers like ballpark the same?
No, not really. But the difference between a concrete and a wooden structure, if you look percentage-wise, they are pretty much the same. So if you check the final emissions with very early, no. But if you try to compare them, then you get something else because you can go down, let's say, 70% by using a wooden structure, and then that still kind of resonates.
Last call. Okay.
Perfect. Oh.
Yeah, thanks. Great presentation and really great to see that you guys are developing open source solutions for this. I actually also had a question about that. Like, up to what extent do you think that this application, which is open source, but it's kind of adapted to your way of working, will be adopted outside your firm? And also, maybe this is also a question to people from other firms, like, do you reckon you would like to adopt this? Or is it maybe also an issue with that this is branded by Link Arkitektur, or what are the issues here for adoption outside Link Arkitektur?
We've the project group, I haven't been maybe reaching out that much communication-wise, so it's a little bit, because we were larger in the beginning and then kind of dwindled down a little bit. But we have 2 engineering firms that are trying it out right now, but you have to run it locally, and you have to like set up your own. It's using Firebase to store some of the information. Maybe we'll switch that to Speckle. That would also be a fun contribution instead. But it's like a little bit of hassle to set it up. So I think that's in part limiting, but as you said, it's very adapted, and it's like trying to find a nice workflow for us. But